Given the second-order linear homogeneous differential equation has a solution of y1 equals x to the power of negative 1, we're asked to determine the general solution on the interval from 0 to infinity. We just solved this problem using the full reduction of order method, and now we'll solve the same problem using the shortcut formula shown below, where if we have a second-order linear homogeneous differential equation in the form of y double prime plus p of x times y prime plus q of x times y equals 0, given y1 of x is a solution, a second solution, y2 of x, is of the form y2 of x equals y1 times the integral of e raised to the power of the opposite of the integral of p of x dx divided by the square of y1. In order to identify p of x, we do have to have the differential equation in the form shown here, where the first term is y double prime, which means for our differential equation, we need to begin by dividing both sides of the equation by 2x squared. Dividing the right side by 2x squared, we still get 0. Simplifying, we now have y double prime plus 1 divided by 2x times y prime minus 3 divided by 2x squared times y equals 0. Notice in this form, we can see that p of x is equal to 1 divided by 2x. Which indicates a second solution, y2 of x, is equal to y1, which is x to the power of negative 1, times the integral of e to the power of the opposite of the integral of 1 divided by 2x dx. I'm going to write that as 1/2 times 1 divided by x dx. And this is all divided by the square of y1. The square of x to the power of negative 1 is x to the power of negative 2. And now let's begin evaluating. We have x to the power of negative 1 times the integral of e, and then the opposite of the integral of 1/2 times 1 divided by x dx is equal to negative 1/2 natural log x plus a constant which we'll call c sub 1. We can leave off the absolute value here because we're solving on the interval from 0 to infinity. This is divided by x to the power of negative 2. Now let's work on simplifying the numerator. Let's first apply the power property of logs by moving the negative 1/2 to the position of the exponent on x, which gives us e raised to the power of natural log x to the power of negative 1/2, and then we'd have times e to the power of c sub 1, which is just some constant. So e to the power of natural log x to the power of negative 1/2 simplifies to x to the power of negative 1/2, and e to the power of c sub 1 is some constant which we'll call c sub 2. So let's go ahead and write this as x to the power of negative 1 times the integral of c sub 2 x to the power of negative 1/2 divided by x to the power of negative 2, which gives us y2 of x is equal to x to the power of negative 1 times the integral of, well, x to the power of negative 1/2 divided by x to the power of negative 2 is equal to x to the power of negative 1/2 minus negative 2 or plus 2, which gives us c sub 2 x to the power of 3/2. And now we can finally integrate. We have x to the power of negative 1 times c sub 2 times x to the power of 5/2 divided by 5/2, or 2/5 times x to the power of 5/2, plus we'll say c sub 3. Notice y sub 2 of x is a family of functions. We only need one solution, so we can let c sub 2 and c sub 3 be any constant that we wish. To have y sub 2 of x be the simplest function possible, let's let c sub 3 equal 0 and c sub 2 equal the reciprocal of 2/5, which is 5/2. In this case, notice we have y2 of x is just equal to x to the power of negative 1 times x to the power of 5/2, which is x to the power of 3/2. And now we're almost done. We know that y1 is equal to x to the power of negative 1, and we can let y2 equal x to the power of 3/2. Because these two functions are linearly independent, the general solution is the linear combinations of these two functions, which means the general solution, because we've already used c sub 1 through c sub 3, we can say y of x is equal to c sub 4 times x to the power of negative 1 plus c sub 5 times x to the power of 3/2. This is how we can solve the given second-order linear homogeneous differential equation using the shortcut formula for reduction of order. I hope you found this helpful.